note is scientific notation is a shortened way of writing numbers that are too large or too small. That means they have a lot of zeros. Now, scientific notation is going to be written in the form A. Now, A is the size of the number in scientific notation. It must be at least one digit, but it must be less than 10. Now, that means when we talk about size, the size must be one non-zero digit to the left of a decimal. The number A must be a number that has one non-zero digit to the left of the decimal. Now, if the exponent, which is up here, is positive, we're going to move the decimal to the right. If it is negative, we're going to move it to the left. Now, something to be aware of. On your calculator, you are going to see 7 times 10 to the 11th power written like this. It's 7 with the E. The E is representing a power of 10, or the exponent, that's what the E represents, 11, and that an exponent goes with the number 10. Now, we're going to brush off the cobwebs because these two numbers are written in standard notation. Okay. 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 Now, because they're written in standard notation, you're going to notice they have a lot of zeros. We are going to write them in a shortened form. Well, first off, the key is decimal places. If you look at A, the decimal is at the back of this number. That's how we start. We want to move this decimal so that I get one digit to the left of a new decimal. The decimal in this number is way in the back behind all those zeros. I want to move it so that there is one digit to the left of a new decimal place. Now, that means that the numbers 1, 5, 2 still have to be written. This will give me x10. Now, x10 is always part of it. Now, between this decimal place and between the 1 and the 3, how many decimal places did I move the decimal? Well, I moved it 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. I moved it 4. I think what happens is there's one too many digits here. I'm going to take out that one. Okay, because they only should be in groups of 3. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 digits. The number or the exponent will be 12 because I moved it from way in the back to between the 3 and the 1. Now, this decimal is at the end. If the decimal is at the end, you have a positive power for 10. That's why it's 12. It's also to the right of where 3 is. Now we're going to do something a little different with B. Decimal this time is showing. The decimal is right here. We need to move this decimal so that it sits between the 3 and the 1. Why does it have to sit between the 3 and the 1? Because I need one non-zero digit to the left of the decimal point. So I have 3.152. It is going to be x10, but this time the decimal was to the left of that 3. When it's to the left, I have a negative exponent. But how many places did I move that green little highlighted dot to behind the 3? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my answer. Okay. Are there any questions? If you have a lot of zeros in the number and we write it with all of the zeros, that's standard notation. We now are putting it in scientific notation. Now the key is there must be only one digit to the left of the decimal. Correct? Scientific notation has only one non-zero number to the left of the decimal. Only one. And also notice the decimal powers of 10 are whole numbers. They are not fractions or decimals. Okay. Now, this is going to ask us to go backwards. This one is giving us the answer in scientific notation. Now, this has a positive 6. Well, that means this decimal between the 9 and the 6 must move 6 places to the right. Right is positive, which means I write 9, 6, 2, 1, 2, 3, 4. This decimal place moved 6 to the right. And I'm going to put little commas in here. This is my answer in standard notation. Now this one, okay, this has got a negative, which means this decimal is going to the left 6 places, which means I'm going to write 962, but this decimal is going left. So I have 1, 2, 3, 4, 5, 6. Now here's something you got to remember. 0.0. This leading 0 has to be there. I've moved it 1, 2, 3, 4, 5, 6 to the left. But I have to put in front of that decimal place a 0, my leading 0. Now, are there any questions? Okay. Now, this next 2 slides is going to ask you, is the number correctly written in scientific notation? Is it correctly written in scientific notation? And then they're going to say, explain if it's not. Well, determine if each number on the next 2 slides is given in, now, it is wanting to say correct scientific notation. If it's not, explain why. Well, first off, you want to look at the power of 10. Is this a whole number? The answer is yes. So far, so good. The power is a whole number. Now, you then look at the digits. Is there one digit to the left of the decimal place? The answer is yes. There's a 2. So, just to clarify, this number is written in correct scientific notation because the power of 10 is a whole number and there is only one non-zero digit to the left of the decimal point. Okay? That's why A is yes. It's got to meet these 2 criteria. It's got to have a whole number for the power of 10. Can't be anything but a whole number. Now, it can be positive, it can be negative, but it's got to be a whole number. And there must be only one non-zero digit. Well, that's 2. This makes this correctly written in scientific notation. Now, B. Well, first off, I don't have a power of 10. If I don't have a power of 10, this is not in scientific notation. I gotta have a power of 10. Not there. Okay. Now, if I look at C, okay, I have a power of 10 that is a whole number. But do I have one digit to the left of the decimal? The answer is no. Okay. Okay. B is not written in scientific notation. No power of 10. C does have a whole number as a power for 10, but it does not have one digit to the left of a decimal place. Okay. It does not have one digit to the left of a decimal place. We have 79. The decimal is behind the 9. That's 2 digits. No scientific notation written correctly. Now, are there any questions with these 3? Okay. Now, let's see if you can answer yes or no. Now, you can either turn on your microphone or you can just type it in the chat room. All I want is the word yes and no. Okay. Chrissy, is D correctly written in scientific notation? Chrissy, yes or no? We'll take a look. Is the power of 10 a whole number? Yes. Is there one digit to the left of the decimal place? But remember, this has got to be in this case. No, because the 9 is behind the decimal place. This is a no, because 1 non-zero, well, 0 is in the decimal place. Can't be to the left. Okay. Now, Rocky, What do you think about E? Is this a yes or a no?
Well, I believe it's a no.
Okay, now let's look. Is there a whole number for a power of 10?
No, it's zero.
Aha, but 0 is considered a whole number.
Yeah.
No, that's right. I'm glad that you do that. 0 is a whole number. Now, I know this goes back all the way to the day 1 and 2 of our class, but 0 is a whole number. And 1, that's a non-zero digit. It is to the left of the decimal place. Therefore, yes, this is a number written in correct scientific notation. Now, Rocky, well, I got you. Take a look at
Yes.
F. Okay, take a look at F.
Mm-hmm.
Yes or no?
Okay. Well, I will say, looking at it,
Right here.
yeah, I'm
Is
looking
this
at
a
that.
whole number? Is
That
this a
is,
whole?
uh, well, it is not a whole number.
That's why you know this is a no.
Yes.
No, this
Now, I
is
have a
not
question for you, though. So, since that is not a whole number, but as we can see on the left side, we have a 1.2, correct? That
correct.
still means that it's not a scientific notation.
Correct. You need two things to be yes.
Oh, gotcha.
Is power of 10 a whole number?
All
Well,
right.
it's a decimal. Decimal is not a whole number.
Yeah.
Now, after you get the whole number for the power of 10, you look at 1.2. Well, 1.2 is correctly written, but the power of 10 is not a whole number. So this is
Oh,
not written in scientific notation
okay. Got it.
because I have a decimal for a power of 10. Go to the power first. If it's not a whole number, then you're in trouble. Right away, you know that that's not scientific notation. If it's a whole number, then you look at the number. Is that decimal before the X showing one non-zero digit to the left? Well, one is to the left of the decimal, but the second half, I have an exponent of 10 that's a decimal. Decimals do not make correct scientific notation. Now, Rocky, what do you think about G? Yes or no?
Um, I'm gonna say, well, I'm looking at the um, exponent, and it's a 4. So I'm gonna say yes.
Yay, she got it. Yes. Yes, this number is in scientific notation because 1, the power of 10 is a whole number. Now, it can be positive or negative, but it is a whole number. And there is one non-zero digit to the left of the decimal in the number before the X. Those are the two things you have to watch out for. The power of 10 is a whole number. Now, it can be positive or negative as a whole number, and even 0 works because 0 is a whole number. And the second thing is 3 point. There is one non-zero digit to the left of the decimal. Okay. Any questions?
No, I think I got it. Thank you so much.
Hey! Okay, here we go. Now, you are going to have a table just like this in Pearson. And this is going to be one that's got a lot of parts to it. You are going to need to take each row and fill in the blanks. Well, on our first row, we have in scientific notation 8.x 10 to the negative 4. Okay, standard notation is going to make me move the decimal between the 8 and the 7 4 places to the left of 8. So when I move it 4 places to the left, the decimal is showing 3 zeros in front of the 8. And remember, I've got my leading 0. Now, column 1, we're back to way back in the beginning. This is old stuff. How do I read in words the decimal 0.00087? Well, hopefully you remember this is 80-7. Now, we have 5 decimal places. 5 decimal places means what number that has a 1 at the beginning and 5 zeros after it. This will be 10 thousandths. Notice the TH, 10 thousandths. This is 87 10 thousandths because I have 5 decimal places. When I have 5 decimal places, this part comes from taking the number 1 and putting 5 zeros behind it. Okay. Let's see. Did I put too many? Yeah. Oh, I did. And that means that this, let's see, 3, 4, 5. Yep. 1, 2, 3, 4, 5. Okay. This should then be, okay, 100 thousandths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Take the 1, put 5 zeros behind it. What's that number? That number is 100 thousandths. Now, this one. Do you remember what 0 to the power of 10 means? It means 1. 7 times 1 is negative 7. this is written -7. Okay. Now, this one has 4 as an exponent. The decimal between 8 and 7 is moving 4 places to the right, which means I now have 87,560. Now notice this word does not have an and. This is written 87,560. That's my number. Now, 5 trillion. Okay. This one got a lot of zeros. This is 5. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Or, in this case, it is written 5 times 10. Now, I have, in this case, how many zeros? 1, 2, 3, 4 sets of zeros. So this is a power of 12. Okay? 1. Now, see the TH? Okay. Now, it says the word 1/1,000,000th. Okay, write out and think about how many zeros does the number 1,000,000 have? Well, this is 1 thousandths, millionths. How many zeros do I have here? I have 6. So this will be 0 point. Now I need 6 decimal places here, which will give me 0, 0, 0, 0, 1. I have 6 decimal places. This is 1/1,000,000th. Okay. And I write it 1 times 10 to the -6. TH is got a negative exponent. Now the last one is 3 times 10 to the 15th power. Now you may not have seen a number this big, but this is 3 quadrillion. These are big, big numbers. Any question with this? Ooh. Okay. Thank you, thank you, thank you. I had someone who told me I wrote a number that was not correct. This is -4. So let's make sure it's 0.12387. Okay, I'm moving it 1, 2, 3, 4. Yeah, I wrote it right. It was correct. And in this time, yep, it's still 87. And this will be 100,000. Yep. Thank you for asking me to check. I am more than willing to do that. Now, are there any questions about this table? Okay. Now, this one, very easy to do. This one is asking you to simplify the expression using exponent rules. Okay, you got to remember those. Then write your answer in scientific notation. And by the way, they want it in correct scientific notation. Okay. This 3 times 9 is going to give me 27. Now, these two are where the rules of exponents come in. This will give me 10. Now I add 4 and 7. That will give me 11. Well, first off, to be in correct scientific notation, 1, the power of 10 must be a whole number, and 2, there can only be one non-zero digit to the left of a decimal place for the number in front of X. Well, we have a power of 10. It's a whole number. But look at 27. 27 does not have one non-zero digit to the left. So this is not written in correct scientific notation. Okay. The decimal for 27 is sitting right behind the 7. Now, we're going to move it over left 1. Now, when we move it left 1, we are adding 1 to the 11. When we move the decimal, which is behind the 7, left, we moved it one place, we are adding 1 to the power of 10. So this is 2.7 times 10 to the power of 12. You gotta have one digit to the left of that decimal point. When we multiply 3 times 9, it is not. It's 27. The decimal is behind the 7. So I've got to move it from behind the 7 to between the 2 and the 2 and the 7. I've moved it one place, which means I add 1 to the power of 11. Any question with this? Okay. Now this one's pretty easy. You are going to look because we are dividing. That's what that line is between. Now we're using the rules of exponents. Okay. We're using the rule of exponents, which is the old stuff. You're going to take and divide these. Then you're going to use your quotient rule. Remember, quotient rule, that stuff we learned. Now, this will give us 35 divided by 7 is 5. There comes the x. Now, this is 10 to the 7th power. 12 minus 5. This is incorrect scientific notation because I have a whole power of 7. Now, I only have a single digit here. Where is the decimal? It's behind the 5, which means 5 is a single non-zero digit to the left of that decimal point. Are there any questions? Okay. Now, this is for ye who like to be computer programmers. This is called engineering notation. It's slightly different than scientific notation. Scientific notation has those two rules. Power of 10 must be a whole number. Now it can be a positive, a negative, or it can be 0. And there must be one digit to the left of the decimal, and that's for the number in front of the x, 10. Well, here, the engineering notation uses powers of 10, nothing different than what scientific notation does. However, the exponent on the 10 is always a multiple of 3 in order to make it easier to read. Now, that may not make sense to you, but I'm going to show you. Okay. Now, it says our naming conventions for numbers change the base of the number. The base is the number in front of the x to the power of 10. Okay. Now, when we see numbers like 1,000 and 3 that are millions or 3 that are billions, we have specific ways of writing them. This is a perfect example. This says 50 million. 50 million. Well, in standard notation, we would have had, in this case, 50, comma, 1, 2, 3, 1, 2, 3. This is standard notation. Now notice the difference. Scientific notation. 5, a single non-zero digit. And the power of 10 is 7 zeros. 7 zeros. But notice what happens here. Engineering notation. We are writing 50 and then we write millions as a power of 10. This is scientific notation versus engineering notation. Scientific notation has its own rules. Engineering has its own rules. Now I'm going to try and make it easy for you. Okay. This table we're going to go through. Standard notation would be 10,000. Scientific notation would be times 10 with 4 zeros. 1 times 10 with 4 zeros. Now notice what happens. Engineering. 10 is the number we're going to write. 10. Now, the number 1,000 is 10 to the power of 3. Notice the difference. Scientific notation, 1 digit before the X. Engineering, you're writing it as we're reading it. 10. And then you put thousands in the power. And that's a 3, because somebody said, can you write that 3 a little better? Yes, I can. Okay. Okay. Now, we have 16 trillion. 16,000, million, billion, trillion. I think I have enough zeros there. Yep. Now, scientific notation will be 1 point 6 times 10 to the 10th. Let's see, do I have enough? 1, 2, 3, 4. That should be 13. 13th power. Okay, because I have to put the decimal between the 1 and the 6. Between this decimal way back here and between the 1 and the 6, I have 13 places, 13 digits. But engineering notation, 16 times, now a trillion has 12 zeros. 12 zeros. 16, there we go. Trillion is the 10 to the 12th. Okay. Now, are there any questions? Okay. Now, this one has a TH word. Okay. This is written 0.421. Now, think about 1,000. because thousandths is the word that's here. See this word thousand? How many zeros are in the number 1,000? 3, which means I need 3 decimal places. Now, scientific notation is written as 0, take that back, is written 4.21 times 10, and I have a negative power. This will be -1. I moved this decimal place 1 place. Now, science engineering notation. I'm going to write the number 421. Now, thousandths times 10 to the -3. Because how many zeros are in the number 1,000? Okay. Okay. And I'm going to finish up these two and then I'll call it good. This is 650. Now, 10 to the 9th power, how many zeros? If I have 1 and 9 zeros, what do I have? I have 600 billion. A billion has 9 zeros. That's the word. 650 billion. My number is 650. 1, 2, 3. It's 1,000, million, billion. See these zeros? That's where the 9 comes from. Now, scientific notation is 6.5 times 10. Okay. And this will be to the 11th power. Now, if I move it 2 places this way, I'm adding 2 to the 9. That's how I got the 10. The 11, 9 plus 2. If I move the decimal from the number in front of the X to the left, I'm adding how many places I move it. If I move it to the left, I'm subtracting. Now this one, okay, this one is written as 0.9. Now 10 to the 6th power is million. 0.9 million. Standard notation. Now, this is going to give me 900,000. See that decimal in front of the 9? 0.9 times 1,000 is going to give me 900,000. and my scientific notation. Very different. This is going to be 9 times 10 to the 5th power. 5 zeros. Are there any questions? Now, a lot of this is very straightforward, but some of it is not. Old stuff, new stuff. Now, you should be doing and have completed cycle 3 and even cycle 3 test, and you should be starting cycle 4. When you get to cycle 4.3, if you have any questions, ask me. I am more than willing to help you out because I know sometimes you may not totally understand, but if you give me a specific example that you need, sometimes I help you a lot more. But these tables, hopefully you've taken a screenshot and you should be able to figure them out. Are there any questions with this? Okay, tomorrow is our last get up. It's our last class. We are going to be finishing cycle 4. I will look forward to seeing you tomorrow. Yay! Have a good day, and I'll be grading projects, and hopefully you will get feedback from me maybe later today, tomorrow. But if I've made a mistake, then you will find a second reader will also help me correct it so that your final grade reflects all of the points you deserve. Have a great day. I will see you tomorrow. Bye. Take care, Yelitsa.